So the purpose of this lab is for us to be able to look at different types of chemical reactions, identify the type of reaction they are, and predict the products of those chemical reactions. So in our first reaction, we are going to be taking some barium chloride solution, and then to that, we are going to be adding a few drops of sodium sulfate solution. So pay attention to what happens when those two solutions are mixed. Remember what it means for there to be a physical or a chemical change. Think about that. Right, in our second reaction, what we're going to do is take a solid piece of magnesium ribbon, and we're going to light it on fire. All right, so once it's lit, observe what happens. And then really closely have a look at what's been left over on that magnesium ribbon. Seeing here some looking like some white powder has been formed. What could that mean? What could that mean was produced? All right, in our third reaction, we're starting off with a small piece of solid zinc in our well plate, and then in that same spot, we will use the pipette, and we're going to add a few drops of hydrochloric acid solution. This is a bit of a slower reaction, but see here. So observe what is happening here, and based on that, predict what products might have been formed. We started with zinc and hydrochloric acid. Remember the signs of physical versus chemical change. Right, in our fourth reaction, we will take a few drops of sodium carbonate, and we're going to add that directly into a free spot on the well plate. So you have our sodium carbonate. Take some observations about what that looks like on its own. And then in that same spot, we're going to add a drop of hydrochloric acid. Right, so we're seeing a very fairly aggressive reaction there. So record your observations, and then based on that, predict what products might have been formed through that reaction. All right, now moving on to reaction number 5. So this one, you won't be expected to predict the products of, because it's a little bit complex. So we're going to start off with potassium chromate solution. That's that yellow solution. And then to that same spot in the well plate, we'll add some hydrochloric acid. So a solution of hydrochloric acid was added to the potassium chromate. Observe what happens. So you probably are seeing quite a difference compared to the beginning. Is that physical or chemical change? You've been provided with the products of this reaction because it's more complex than the others, but you should still be able to identify the type of reaction. All right, now moving on to reaction number 6. So in this reaction, we are going to be adding a few drops of hydrogen peroxide solution to a spot on the well plate. So hydrogen peroxide is a clear solution. And then to that same spot, we're going to be adding some manganese dioxide. So what manganese dioxide does is it acts as a catalyst to speed up the reaction. So think about what might be coming off of that mixture in those bubbles. So I will tell you now, manganese dioxide is a catalyst. It's not actually reacting with the hydrogen peroxide, right? There's a different kind of reaction that's happening here. It's not hydrogen peroxide and manganese dioxide. Manganese dioxide just speeds up another reaction. So think about what kind of reaction that would be. Think about what bubbles were being given off from that mixture. All right, now reaction 7. So we're back to using some solids. In reaction number 7, we are going to be taking some solid iron pieces, so that's our iron. And then to that same spot on the weld plate, we're going to add a few drops of copper 2 sulfate solution. All right, and then make some observations about what happens when that copper 2 sulfate solution was added to the iron. Right, based on those observations, try to predict what products might have been formed. Right there, they're just trying to make sure everything is nice and combined, right? That's where you really can see, evidence of chemical change. All right, in reaction number 8, third to last one, we're going to use a pipette once again and add a few drops of copper 2 nitrate solution to a free spot on the weld plate. The copper 2 nitrate is that classic blue color. Now to that same spot, we'll use a different pipette and we're going to add a few drops of sodium phosphate solution. All right, this is a pretty cool reaction. So the sodium phosphate was added. Record some observations about what happened when those two solutions were mixed, and use those observations to predict what products might have been formed. Now, you probably can predict what has been formed based on the change we've just observed. All right, now reaction number 9. So in reaction 9, we're taking a small piece of solid magnesium ribbon, and then right there, we are adding a few drops of nitric acid into that same spot on the weld plate. All right, so this is looking pretty aggressive. So record what you observe happening, and then based on that observation, make a prediction about what products might have been formed. This is also a reaction that if we were doing it live, you would probably see it go for a few minutes actually. So we'll move on to our final reaction in this lab. Reaction number 10. So for this reaction, we're starting off with a small piece of solid copper wire. So this is copper. And then we're going to use a good old trusty pipette once again. And to that copper, we're going to be adding some silver nitrate solution. So this solution that's being dropped on the copper is silver nitrate. So observe what happens to that copper wire as it is being mixed with the silver nitrate solution. And then based on these observations, right, I'm not going to give it away, but I think you should really be able to predict what products are being formed. Think about what might be now coating that copper wire. All right, and those are all 10 reactions completed for us. Just now a quick visual to see an overview of all of them. What you'll be doing for this lab is you're going to be making sure you go through your observations table, finish up everything that was blank in there, fill in all the reactants with their chemical formulas, all their products with their formulas, describe the products, so write your observations, and describe the change.